currently. It is the most happening thing around us right now. Most of the jobs you see in the market will be related to the AI in now or in near future. So it's very much needed for you to learn about AI and how we can actually interact with AI in our day-to-day life. That way, everything in the future will be related to AI. So it is better for us to be part of it rather than be lost to it. Okay, so let's move forward. So what is AI? There is a misconception AI and ML are almost the same, but it is not. AI is a very broader concept. It is an overarching term which has many different technologies or many different concepts within it. As you can see in the picture to the right, the artificial intelligence has AI means artificial intelligence. That's an abbreviation. And artificial intelligence has many different subtopics within it. The machine learning is one, the deep learning is another, there is natural language processing, robotics, expert systems, all of them come under AI. So, and that's why it is AI. So everything, if you talk about AI, it's a very bigger concept, and you can have very specific things within it. So it's not completely machine learning, because machine learning is part of it. So what is machine learning? Machine learning is a type of artificial intelligence that allows computers to learn without being explicitly programmed, right? So what it means? It means that computers can automatically learn based on the input you give, and then you make them learn from that input, and the next time when you give similar input, it can predict the output. So that's machine learning. So you are not explicitly programming something like we do in the traditional programming, where you provide the input, you expect the output, and when the input changes, you need to change the logic as well, right? But in the machine learning, you are making the machines to learn based on the input, and the next time when you give similar input, you don't have to change any logic. The machine has already learned from it, from the previous inputs, and now it can predict the new output, which is very closer to what you are expecting. So that's the difference, right? And the deep learning is basically a subpart of machine learning, where we use the artificial neural networks, very similar to neurons working in our brain. It's a concept. It's kind of a multi-layered hierarchical, not hierarchical. It's a tiered, multi-tiered layers of processing networks, which actually takes the input and prune and understand and process the output based on that, right? So that's deep learning. So that's the core difference. Machine learning is very simple. It uses linear regression and simple mathematical expressions to predict the output, whereas deep learning is more advanced, which actually uses large amount of data to predict the output. So that's the difference between machine learning and deep learning. So this is the slide which is actually showing the difference between machine learning and the deep learning. In the machine learning, you need to have a person called a data scientist to extract the features out of the data, okay, you would give, and then based on the extraction, you choose the right algorithm, and based on that algorithm, you try to predict the output. But in deep learning, everything is happening automatically. The machine itself is using several layers of processing, to understand the various features involved in the data, and based on that it is predicting the output. To give you a best example, so think of it this that car image as a Tesla autonomous driving, right? So if you have if in the traditional machine learning, if you have to understand the images, so Tesla, what it does is when you put it in self-drive mode, it uses all the cameras, the videos, the images from all the cameras to process the road condition, and based on that it will drive the car, right? So in the traditional programming, a person will have to sit in the data center to actually extract all the different data points, and based on that, like the condition of the road, the car availability, maybe there is a roundabout, all those things it has to that particular person will extract out of the data, and based on that it will he will use a proper machine learning algorithm to predict the next driving mode, right? Whether to turn the steering to the right or to the left, or to go straight. That is something which the person has to do manually. Here in the deep learning, everything is automatically happening. That's why when it is said that as and when these cars drive on the road, they become more and more expert in driving, because they actually will be learning from their own mistakes. All these deep learning algorithms will be learning from their own mistakes, and they'll be able to drive without any issues in the future, and there'll be less and less accidents. That is why all these autonomous vehicles will become the future because the more they drive, the more they will be adjusted to the various road conditions and to the various circumstances on the road, and then they will become more and more expert in doing the driving, and there'll be less and less accidents. So that's the key difference between deep learning and the machine learning. Okay, we'll pause here and we'll take some questions. So this slide is talking about the artificial intelligence, the difference between artificial intelligence, the machine learning, and the deep learning. Okay, so the artificial intelligence, as I was explaining, it's an overarching term, right, which enables machines to mimic the human behavior through particular algorithm. Okay, so and it is at the high level, so you can pretty much embed anything. You can tell, okay, a robot is an artificial intelligent robot. A natural language processing software is an artificial intelligent software. So you can pretty much plug in everything into this field, into an artificial intelligence system, and you can just call it as an AI system, right? But ML is a very specific learning, a very specific field wherein you are making machines to learn based on statistical methods, and they keep on improving with the experience. Whereas deep learning actually is a study that uses the neural networks to imitate functionality just like human brains. Okay, so I already talked about what AI, what ML is a subset of AI, DL, deep learning is a subset of machine learning. AI is compute algorithm which exhibits intelligence through decision making, and ML is an AI algorithm which allows system to learn from data, right? So if I take the robotics example, it is pretty much AI. It exhibits human intelligence, right? It's already coded into the robot, so there is no data needed here. But here you need to pass the data, and it will predict the next outcome. And in deep learning, it uses several layers to analyze the data and provide the highest possible accuracy in the deep learning. So so the last line actually is the key. Is you need to remember this. when you want to differentiate between AI, machine learning, and deep learning. The aim of artificial intelligence is to basically increase chances of success and not accuracy, right? What it means? It means that it only focus. So if a robot has to actually walk, okay, so how successfully it is walking, that's all artificial intelligence cares, right? But in the machine learning, the aim is to increase the accuracy and not care about the success, because it is predicting and it wants to predict the closest possible output you want to give. Like when you say prediction, right? So think of it as some kind of weather prediction, right? And based on the condition of the weather, the wind direction, the clouds availability, all that, and the precipitation, the humidity, all that actually decides on whether it will rain today or not, right? That is a prediction. And sometimes the predictions can go wrong. They might say it might rain today, but it might not happen, right? So it is not accurately predicting. It is trying to be as close. It is not caring about the success ratio, but it tries to be as accurate as possible. So based on all the different things, all the parameters to predict a weather, it tries to be as accurate as possible, but the chances of success are not that high, right? Because it can rain today or it might not rain today, right? So that is what machine learning does. But in deep learning, since you are using lot of data, lot of layers to process the data, your accuracy will be much more higher in deep learning compared to machine learning. So that is why these autonomous vehicles uses deep learning, because you cannot say, okay, if I don't turn when I have to turn right, if the accuracy is not correct, there might be an accident, right? Because you don't want to use machine learning in autonomous vehicles, because the accuracy is not that high in machine learning. But in deep learning, the system has learned from its own mistakes, and the more and more it actually makes the mistakes, there is a feedback loop to correct that mistake. So that is why deep learning is better suited for all these complex AI things which we need for our future, right? That is the difference. That is the key difference. So we will pause here, and if you have any questions, I can take it. Otherwise, we'll move to the next topic. Okay. So, all right, no questions. Let's move on. Okay. So traditional programming versus machine learning. So in the traditional programming versus AI. So what is the difference? So in traditional programming, you have inputs, you have outputs, you use data structures, you use computation, right? So all this go into a software, and you build that software and you release it into the market, right? So for example, if I have to build Amazon.com, you know how to code it. You know when the user try to purchase something, you just click on a product, you go through the purchase experience like checkout, payment, shipping, and then finally order, right? That is the traditional software. So you actually going through a specific set of rules or well-defined steps of well-defined instructions which have certain inputs, certain outputs. You use certain data structures within it, and finally the result will be an order, right? The computation, once it goes through everything, it gives us a order ID or something, right? That's traditional software. But in AI, you are actually using the raw data, the labels, the algorithms, okay, the patterns and the feedback loop. So what is the difference here? the input is a raw data. Raw data is nothing but it has everything including the result. For example, you have a clinic and you want to actually build an algorithm to predict the next person who is walking in based on his age, whether he will be sick or not, right? So you take the say for example, if you build a table and you ask your secretary or your colleague to note it down, and he will note it down like, okay, the person who walked in was a male, okay, there is a gender, the person age was 22, so you recorded the age, the person was sick or not, you recorded the result as sick, yes or no, right? So it has 3 columns basically, and it might have more, but I'm just giving an example. So you recorded, you build that table, you ask your colleague to build that table, and he has pretty much recorded for the whole day all the people who walked into your clinic, and he pretty much built that table, and the table is ready, right? For the next day, when people walk in, you just want to predict, right? And so you take this data, you feed it into an algorithm, okay, to a machine learning algorithm, and based on the accuracy, so there are several machine learning algorithms which are already available in the market, and based on the accuracy, right, whichever machine learning algorithm will accurately predict the output based on the inputs you have provided, you will choose that algorithm. So this machine learning data scientist job is to go through several algorithms to check which algorithm actually predicts the closest output, and based on that he will decide for this input, this is the algorithm which suits best for this output. So that is the job of a data scientist, and the way they do it is they collect the raw data, like you ask your colleague to prepare the data, then they label the data. The labeling is like, what is the labels is, the label is the columns which you have decided, whether the age is one of the column, the gender is another column, the result is another column, right? So you pretty much recorded all of it, and then that is the labeling, right? Labeling of raw data. And the third one is choosing an algorithm, which algorithm actually predicts the accurate result, right? So that is the algorithm part. And the patterns is actually the grouping of your data basically, right? So you predict the pattern of, based on this input, this is the pattern which might be the output, right? So that is what AI is dependent upon. And the patterns are mostly not for machine learning but for deep learning, because deep learning solely depends on patterns. Feedback loop is, again, it is something which I already talked about. So a deep learning algorithm goes through the feedback loop to correct itself whenever it sees there is a negative outcome of something which it predicted. So that is what the feedback loop all about. So AI is totally different compared to what traditional programming was doing, right? So this here I'm talking about what is AI and machine learning and what is the traditional programming, right? So in the traditional programming, you have data, you have algorithm, and the outcome was the result, right? In the machine learning, you already have the data, you already have the result, but the outcome is an algorithm. That is the key difference, right? So what you are trying to get in the machine learning or the AI is to get the right algorithm for the results of based on the data, right? So the data is the input, the result is the output you want to predict, and the algorithm is what you will select, which is based on the most accurate results which this algorithm can predict. So that is the key difference. Any questions? By the way, quick time check here. Okay.
So hi, my question is that who can create the algorithm? Like we use the built-in algorithm or we create algorithm?
The algorithms are already there. I mean, so there are several algorithms already in the market. The data scientist's job is to just use one of these algorithms, which are already created based on a lot of research and using mathematical expressions. So we just need to use it. You don't have to go and create it because a lot of research has already been done on that side, and they are all freely available for a data scientist. You just need to use one of them to predict the closest match. Okay, and I will be talking about that. Any question? Any other question?
Yeah, could you please walk through back to this AI, like from raw data and then back and then to feedback loop, very quickly? Thank you.
Can you repeat your question, please?
Sure. Could you please walk back through this AI process, like from raw data to feedback loop?
Sure.
Yeah.
So the AI instead of the traditional inputs, you will have the raw data, which is actually the data which is not labeled, basically, right? It is the data which you either collect through some logs, you either collect through some structured table, right? You already might have something based on your previous software you had developed, and based on that you will have a raw data. Now the next thing you need to do is label the data so that you can feed it into a specific algorithm to get the accurate results. So that is what a data scientist does. A data scientist tries to collect the raw data, label the raw data. Label is nothing but giving names to specific columns within the data, or making sure that the particular input has a proper name so that it can make logical sense for any human to look at it, right? So that is labeling. So labeling is some second thing which data scientist does. The third one is algorithm, choosing the right algorithm so that the prediction can be done on the labeled data. And finally, the patterns and feedback loop are mostly for deep learning, where we actually try to see the patterns within the data when the data is very huge. If you have millions of records, billions of records, you need to see what is you classify the data into different patterns, they are based on the characteristic, and then you arrive at a decision on what type of data it is. So I'll be talking about that as we move forward. You will understand more about it. And the feedback loop is nothing but the loop within which a particular algorithm tries to predict the output, right? The feedback loop, a particular algorithm actually tries to one second. Okay, the feedback loop is nothing but a loop within which a deep learning algorithm tries to correct itself by feeding the input again based on the outcome of a negative outcome. So if you are in the autonomous vehicle condition, right? When the vehicle was driving and it met with an accident, that is a negative outcome, right? So the deep learning algorithm will feed back that set of the images, the images of that car, basically and it tries to avoid that outcome in the future. So it might have a road obstacle, somebody might automatically came in while the car was driving. So all that has to go into the input again, and the deep learning algorithm will try to correct that next time. So that is the feedback loop. Is that understood? Okay, I'll move forward. So AI is around us, okay, and you can see AI is pretty much everywhere nowadays. You can see AI around in automation, in data-driven decision making, in personalization, healthcare and medicine, natural language processing, image and video analysis, financial services, recommendation system. Pretty much you go to any field, any domain, you see AI today, and it is becoming widespread across our industry because the usage is so easy and it is so useful that it is taking away a lot of the stress out of all these industries, all these different businesses people run. It is taking the stress out of it. The reason is pretty much everything is becoming autonomous, right? And more people are becoming jobless because of that. So all the things which were previously done by humans, and humans are prone to errors. Now these AI algorithms are able to do that not only with accuracy but also with ease and with very less cost, right? Because of that, people are becoming jobless now, and most of the systems are becoming autonomous because of AI. So, and one of the key things which I wanted to highlight here is the healthcare and medicine is one of the field which is using AI and machine learning to be very precise, to actually try to solve some of the problems, some of the big problems humans face. One of my friend was telling me that genomics, there is a field called genomics. It actually uses machine learning language to model our genes, and one of the things which it is trying to do is how to accurately predict the diseases in the future based on the gene structure of humans. And so when a child is born, based on the gene structure, they can predict whether he will get cancer or not, right? In the future, they can predict whether he can have heart diseases or not in the future. So that is what the level of level of usage we have for machine learning right now, particularly in the medical field. So some of these diseases which humans, the genetic diseases, they are trying to resolve that by fixing the genes within the newborn child, by generating a pattern of all the genes and seeing whether any gene is not correctly built within the human body. So it's a very evolving area, and it's a lot of work is happening there as well. So it's not only, we only see and hear about all these new technologies like Tesla cars, driving, recommendation systems, like in YouTube. You watch a video, and if you see similar video, you're talking about something, or you're thinking about something, you search something you want to purchase, and next time you see only ads related to that. How all that is happening. No human is sitting behind the scene to track all your actions. Everything is happening through AI. Everything is happening through machine learning. So all these predictions which are made, they are going through the machine learning algorithms. So anytime if you want to try, you can try. Even if you hear a song or you want to watch a YouTube video, you just click, you like it, the next time the similar YouTube video appears, right? So all that is, and it is very instant also. It is not something which somebody is tracking over the period of time and then they will send you the recommendation. It is happening instantly, and that is happening through machine learning and AI. So social media advertising also, I talked about it. You want to purchase something, you just checked it once online, and in the next moment you see ads related to that. The last thing is the ethical consideration. Ethical consideration is something which in machine learning is needed at the moment, and it is subjective. Basically, every machine learning algorithms, all these different algorithms, the data models, the large language models. You might have heard about ChatGPT. You might be using the ChatGPT already. So all these large language models, which are so prevalent in the market currently, they all are uses by us, the people who have created those models. If they feed the data into those models, and the data needs to be the data which they feed, if it is biased data, or it has problems with it, like some violent content within it, the LLMs or all the models which ChatGPT or other AI chat agents use, they might also predict wrong output for you. So that is why ethical, when you decide on the ethical any AI system, the ethical consideration is must, where you decide whether you need a particular algorithm for a particular field or not. For example, you cannot have AI system fighting for you. For example, you are building a fighter jet, and you don't want the fighter jet to be driven through AI, because what is the guarantee that it will not kill innocent people, right? So that is something which the people are talking about for the AI, and it is something which will come in the future as well. So what is narrow AI? There are two different types of AI, narrow AI and strong AI. So everything you see currently in the market or around us is all narrow AI, because it is all related to a specific field. It is not generic enough for anyone to go and consume it like human beings, right? You ask me to work on AI, I will work today on AI. You ask me to work on cloud tomorrow, I will work on cloud. And you might ask me to work on something else, I might work on something else. I might go and cook, I might go and do the lawn mowing. So several things I can do as a human, but AI algorithms are still limited to some certain fields or certain domains currently. And you can see all the things we see here: email spam filters, text to speech, speech recognition. All these are very specific to that a particular field or particular functionality. They are not widespread, or they cannot do everything like humans can do. So that's why they are all categorized as weak AI. So weak AI built to simulate human intelligence, but it is not intelligent like human. Whereas a strong AI is built to copy human intelligence, and strong AI is a theoretical concept which actually theoretical next level of AI, or the true intelligence, right? They call it as true intelligence. This is something which you saw in a Terminator movie, where the Skynet, the software they had built, it actually decided that humans are a threat to itself, and it decided to eliminate all the humans from Earth, right? So because it had true intelligence, it was able to do it, and that is something which is very, very dangerous, having human intelligence for computers. And that is, I am hoping that will never happen, but you never know. I mean, large language models are also a concept. It was not a reality 10 years back, but it is a reality now. So it might happen that there will be a truly intelligent system in the future which can replace humans. So it's all possible now with the way industry is growing. So how does machine learning work, right? With that, I'll pause a little bit. Do you guys need a little break? Because I am getting into a large language models, and I think with that we'll be very much into the large language models, and you will see some examples too. So you want to refresh and come back? I'll probably, if you want to do that, we can give a 5 minutes break and we can join again. You can chat as well if you don't want to speak. You want me to continue?
I think so. We take a 5-minute break, so it's good.
Okay. All right. So let's connect after 5 minutes. I'll go on mute, and this will be live. So pretty much I'll stop the recording, and then we can go for 5 minutes break. All right. So how does machine learning work? So in the machine learning, the concept is really simple. You know your data. You collected the raw data. You labeled the raw data, and then you need to feed that data into machine learning algorithm, right? Once you feed the data which you feed into the machine learning algorithm is called the training data. Then you train the machine learning algorithm. The training is a process where you pass the data to the algorithm, you check the accuracy of the prediction the machine learning algorithm does, and pretty much you feed the new input data, okay, every time. You try to see the prediction, and if the prediction is acceptable, you close the loop, or else you keep doing the same thing again and again until you get the desired results, right? So that is what you actually, as a data scientist, you do, wherein you take the raw input, divide the data into multiple sets. One of the set is called training data, the other set is called the validation data, and the third test is the test data. Okay, so 3 sets. Usually the ratio is 80, 10, 10. What you do is, if you have 10 records, 8 records you take to train the algorithm, 1 record you take for validating the algorithm, and the final record, which is the 10th record, you will take to test the algorithm. So that is the 80-10-10 ratio. So 80% of the data will go into training, 10% for validation, and the 10% for the testing. So that is the machine learning workflow, where you keep on doing this until you get the desired machine learning algorithm. So there are several types of machine learning algorithms. One is called supervised machine learning, the other is unsupervised machine learning. There is a semi-supervised machine learning, and the last one is called reinforcement learning. So let us go and check one by one what are these different types of machine learnings. The supervised machine learning is the machine learning task of learning a function that maps an input to an output based on example input-output pairs. We already talked about the clinic example where you asked your colleague or your secretary to take the data or note down all the people who are walking in to the clinic and categorize them as male or female, and also record their age and whether they were sick or not, right? That is the labeling you have already done. You understood that, right? That is, so you have a clear input, you have clear output, sick or not. Clear input is your male or female, your age, and the output is sick, yes or no, right? So that is called supervised learning, where you know the result, you know the input clearly, and then you have labeled it correctly, and you know the outcome, that is what it is. So easily you can use one of the algorithm to predict the output. That is supervised machine learning, right? So you know, so it maps an input to an output, right? That is supervised machine learning. So supervised machine learning has two types of algorithms. One is called classification, and another is regression. So these are the two problems. So machine learning, the supervised machine learning algorithms solve, and depending upon what are you trying to do in supervised machine learning case, you have to select the algorithms appropriately, right? The classification, in the classification case, you want to classify certain things depending upon the input, right? For example, these are the examples. I already talked about sick, yes or no, okay, true or false. Something like if you are getting an email and you got an email from a new person, your Gmail sometimes put that email into the spam box, right? A spam folder. So in that spam folder, how it decided whether it's a spam or not, because that email was from a person who was unknown to you and had certain characteristics. Based on that, the Gmail algorithm, machine learning algorithm, decided that this email doesn't belong to within the inbox, it belongs to the spam folder, right? So that is true or false. So it is spam true or spam false, okay? So it is so in the grouping of in the true or false, male or female, etc. All these are actually the classification problems, right? And depending upon the classification, there are several algorithms which are already available: random forest, decision tree, regression algorithm, and support vector machine algorithm. These are all classification algorithms which are already available. And when we go to the advanced course, we will do examples for all this, but this is a basic course, that's why I'm just giving the theory for you so that you can just digest it. You know what it is, and based on the basic concepts, you can pick up in the next advanced course, okay? Regression. In the regression, you just handle the regression problems where input and output variables have a linear relationship. What it means? So you want to predict the continuous output from the input, right? For example, I talked about the weather prediction. The market trend analysis is another thing. So you want to continuously predict based on the input. That is in regression, you actually continuously predicting the output. Here in classification, you stopped once you classify the problem, right? Whether yes or no, true or false, something like that, you decide, and the outcome is immediate, and you don't do anything with it. In the regression, you continuously do something based on the input data which is keep coming to you, and you continuously predict the outputs. So that's regression. So both are working on the labeled data. So supervised learning is all about labeled data, where you know everything, where you know the data, where you know the parameters, where you know the input, and you just want to predict the output. In unsupervised case, you don't know the input, you cannot label the data, you just can take the raw data and you feed it into a algorithm, and in that case what it does is it just classifies the data or categorize the data based on the observations or patterns it can see, right, on the data. So in unsupervised case, so in this case, so this picture actually in the supervised case, you can see the picture of the in the right the picture shows that the data is a labeled data of animals, and you have labeled it as cow, elephant and camel. You feed it into the algorithm, you allow the algorithm to process and predict based on the input you give whether it's an elephant or camel or cow picture, right? That is supervised. So you know clearly the data. In unsupervised case, you don't know the data, you don't know what animal it is, you just feed the data because the data is so huge, you don't have the time or money or patience to label the data. So you just go and feed the data to the algorithm. The algorithm doesn't know the data what it is. It just based on the characteristic, it classifies the data into different outputs. So it sees the picture of elephants, it just categorizes it as similar output as elephant. It sees camels, it categorizes as camel, it categorizes cows into a cow category, something like that. So pretty much this is not classification because you don't know what it is. So we call this as clustering. So what is clustering? Where you are grouping all the similar output into a common group. So that is clustering. So this algorithm, unsupervised learning, is a clustering, uses clustering to predict the output based on the input it is which is given to it, right? And there are several clustering algorithms available, like k-means clustering algorithm, mean shift algorithm, DB-scan algorithm, principal component analysis, and independent component analysis. And you don't need to know all of it. Just remember one or two, and that's all you need to care about. That way, when somebody asks you, at least know what kind of algorithm goes into what group, right? And association is something which is building the relationship. So pretty much, if you give a raw input, you need to the association algorithms build a relationship of that data into something which it sees based on the patterns. For example, if you give pictures of humans, it might categorize it as human. It will build that relationship with a human group, or it will if you give pictures of animals, it might associate it with animal groups, and birds with birds group, something like that. So relationship association is actually refers to identifying typical relations between variables of large data sets. It determines the dependency of various data items and map associated variables to that particular category, right? Typical applications include web usage mining and market data analysis. So in web usage mining, what we do is we actually collect the data from all the websites, and depending upon depending upon what that particular website does, we will collect the competitor analysis, right? For example, if I am stock market, if I have a stock market application, so if I have several stock market applications in the market, so I collect the statistics of what usage my application has with other applications, and that way I know who is leading in the market in terms of usage, right? Yahoo Finance is one example which is very widely used in the stock market. So it is the top one website which is used by everyone. And there are several competitors to it, but they have lesser usage compared to Yahoo Finance. So that's web usage mining, and the market data analysis is something which anyone can do depending upon the data it collects for a particular domain. So that is all. So it's all raw data, no labels to it. You just collect it and you just create patterns and you just cluster or associate, build associations based on that. The third category is semi-supervised learning. In semi-supervised learning, you want to take the advantages of supervised learning and take the advantages of unsupervised learning and club them together. So what is the advantage of supervised learning? In supervised learning, you know the label data, you know the data, you have labeled it, you know the output also. So the algorithm predicts clearly whether it's a camel, cow or elephant, right? So that is the advantage. It clearly says what it is, right? That is the advantage. In unsupervised, you can only do clustering, you can only group them. So since in this case, in semi-supervised, you want to take the advantage of both. So you have large data set, right? So you collected huge amount of data from maybe Facebook, from Twitter, maybe large websites, and you have tons of data, and you now need to build an algorithm on top of that, right? So what you do, you first feed it to the unsupervised learning, right? In the unsupervised learning algorithm, you cluster them. Okay, clustering. You use a clustering algorithm to cluster the data. Okay, and now it has clustered it. So pretty much it has created groups for the data. Now you can go and label the data and predict the output. So pretty much you are using both, right? You are labeling, you are using the supervised learning, you are using the unsupervised learning. You are first creating the groups for the large data, and then you go label the data based on the groups, and now you can predict what is the output for that particular input. And that is how you can save time and money, right? Because you don't want to keep labeling large amount of data, because it might take months or years together. You just feed it to the algorithm created the groups, now you went ahead and you labeled it, now you know what to predict based on the algorithm. So these are the three major categories, and I hope you understood it. But to give you a simple example, this is the best example which I have written. Then consider the example of a student. If the student learns from the teacher, that is supervised learning. If the student learns on its own, that is unsupervised learning. And the student learns under the guidance of the teacher, that is the semi-supervised learning, right? So which means a student revising the concept after learning under the direction of a teacher is a semi-supervised learning, right? So that is the best example you can remember for these three categories. Okay. Any questions before I proceed? Okay. The reinforcement learning is the last category. The reinforcement learning is a feedback-based process. Here, the AI component automatically takes a stock of its surrounding by hit and trial method and takes action. So we already talked about Tesla example, right? So it captures the images from these cars, all the images and the videos. It tries to make a prediction. If the prediction goes wrong, it tries to correct itself through the feedback mechanism, right? And any positive outcome will be rewarded by performing good action. So the reinforcement learning component aims to maximize the rewards. Okay. So what is reward? Reward is a positive outcome. So if it is positive, the outcome is positive, you reward it or you punish it. That is reinforcement algorithm. So there are two types of reinforcement algorithms. One is the positive reinforcement learning, where you try to reinforce a stimulus, that is the action of the specific behavior of the agent. So for example, you are making a dog, you are making a dog to sit, and you are training the dog to sit. So what do you do whenever a dog, you give a command, sit. If it sits, you reward that dog by a cookie or something. So that dog will build that experience. Okay, if my owner says, trainer says sit, if I am doing this, then that means I am actually being rewarded with a cookie, right? So that is positive reinforcement learning. In negative reinforcement learning, taking the same dog example, if it sits, okay, and if it doesn't sit, what you do, you make it to sit, and you avoid the standing reinforcement. That means you avoid the negative behavior by making the dog to sit. That way, you are trying to avoid the negative outcome by reinforcing the positive outcome and strengthening that specific behavior. That is negative reinforcement learning. So avoid it or reward it, right? Avoid it or reward it. That is, those are the two things in reinforcement learning. Okay, we are entering into the world of large language models. Okay, so this is I'll go very quick from here because there are very less number of slides left after this. So what is the large language model? We all know about large language models now. Hopefully you all know about it. Large language models are AI systems that process the human language. So ChatGPT, what is ChatGPT? ChatGPT is an application which is using large language model behind the scene. GPT 3.5 was the model which it was using. GPT-4 is the new one which they have released, and it is supposed to be the best model available in the industry today. So these large language models will have billions of parameters on which they are trained. When I say parameters, they are nothing but the inputs which we can change to change the algorithm behavior. Okay, those are called parameters. So in the case of our dog example, the parameters in our dog case was the experience and the memory of the dog. So if I change the memory or the dog's experience, the dog was able to sit because now he was able to understand. His experience taught him that, okay, by sitting I am obeying the command of my trainer. So based on that, it is sitting. So that is a parameter. The memory of the dog and the experience of the dog are the parameters based on which you train the dog. Likewise, in models, you have several parameters, billions of parameters, which you can tweak to change the behavior of the model. So how the rise of large language models started? So the first large language models was created by Google in 2017 when they actually published a paper called Attention is What You All Need. In that technical paper, they actually proposed this BERT algorithm. What is that BERT? Bidirectional enforcement from transformers. Where basically this algorithm actually makes the prediction of the next word based on the context of the previous word. So that was the key difference. There were already machine learning algorithms which were available in the industry before. There were two types of neural networks. This BERT was actually the NLP algorithm. So natural language processing algorithm. So they were already algorithms available. There were two types. One was called convolutional, another was regression. So these two NLP algorithms, they were not predicting the output based on the input. They were actually going within a sequence, and they were based on the previous input. They were going and predicting the next output. So they were going in the sequence. So they were always moving forward, and in the unidirectional. They were predicting the things in the unidirectional way. But BERT actually introduced bidirectional prediction, where it was not only it was giving the prediction based on the previous input, it was also giving the prediction based on the next. So this was the main proposal they. So any algorithm, and that was that their algorithms was called transformers. So that was the key. That was the revolution they created. The transformers had encoder and decoder. So in the encoder, basically, so they introduced this multi-head attention block, wherein, or the logic, wherein you have the you are actually seeking you are taking the input of the previous word, and the output you can see there is a output, right? So here, so they are not only trying to see the previous input attention, they are focusing on the previous input and as well as on the following output, and based on that they are predicting the next output. So this is the transformer algorithm which they predicted, and that revolutionized is large language models. And you can see BERT started in 2017. After that we had GPT-2, and after GPT-3, pretty much now we have a trend. Basically we have a boom where every other company is trying to build large language models, and you can pretty much see now they are very much prevalent. Everywhere you see large language models, and they are keep on making it. So we also can make large language models. It takes time, it takes effort, but anybody currently can build a large language model, and that is not that difficult, but it is not easy as well, because it takes a lot of effort to build a large language model. Alright, so with that, let me go to the Hugging Face. The Hugging Face is an interface which actually provides the models, the free of cost, large language models free of cost for you to explore and use and deploy. And also it makes it easy for you to leverage large language models. They have a library, a Python library called Transformers, which actually simplifies the downloading and training of models. The library gives the developers the efficient way to include one of the ML model hosted in the Hugging Face and create ML pipelines. When I say ML pipelines, it is what you want to do with the model, right? What you want to leverage from the model. That is something which you can define in the pipeline, and the model will automatically give you the output based on that. You want to generate an image, it will give you the image. You want to talk, you want to write a story, the model will give you a story. You want to summarize something, it will summarize for you. So pretty much anything you want to do, you define in the pipeline, and the model will give you. So basically, in the traditional programming, you were doing everything, you were writing logic for it. Now you just define it, and the model will give you that. Okay, so that is the Hugging Face part of it. So okay, any questions in Hugging Face before I move on? So in the next class, we will do some examples on Hugging Face inferencing, okay? And what we will do is we will actually download a model. We will try to do some predictions. We will also try to use the model to generate some text, okay? So like you do with the ChatGPT. So in the next class we can do that. It will be little detailed, and you can also do some programming in that. So pretty much if you come next time for the next class, please log in with your machine, because we will have a workshop wherein we will learn how to call the model, how to download the model, how to even leverage the model, okay? So this is all theory, so you don't have to bother about it today. LLMs evaluation. So what are LLMs? LLMs are large language models. So in the large language models, the first thing which came up was Q&A bot, wherein you gave, what is a Q&A bot? You gave an input and the model predicted you gave a question and the model predicted the answer, right? So you didn't have any context in it, right? So you asked what is the capital of United States. It said Washington DC, and when you said what is popular in it, it was not able to answer it, because that's just a Q&A bot. You gave a question, it answered it. It didn't have the context. So in the right side picture I'm showing, for large language models, what are the different dimensions which are available. So one of the dimension is prompt. The short-term memory is the next dimension. The external data is the third dimension. The tools is the fourth dimension, and the extended tools is the fifth dimension. So how these LLMs are evolving? So first you had Q&A bot, which had no memory, short-term memory. So it didn't give you answers based on the previous input or output, right? So now we have chatbots. In the chatbot, you have if you go to the ChatGPT, it will give you the output based on the previous output. So pretty much it has the short-term memory. So it is giving you output with context, right? In the context, it is called in context learning. It learned from the context, it gave you the output. So that is which related to the chatbot. So two types of text completion and question answering and classic NLP problems. They both have the prompt. The input is called the prompt, and which you give. Previously in the traditional programming we call that as input, but in case of large language models, that is called as a prompt. So when I say prompt, it is nothing but the input or the question you give to the large language models. So you gave the prompt, you gave if the model has a short-term memory, then it can build a conversational agent called a chatbot, right? So if it has short-term memory, you can build a chat agent. The next level is called RAG. It's called Retrieval Augmented Generation. This is the most prevalent AI application building strategy currently available. So what it is doing, the retrieval augmented generation. So what it is doing, it is trying to connect to the external data to give you the output along with the short-term memory and the prompt. So why we need that? Can you think why we need that? Because in the RAG, you need to in the chatbot, when you ask who is the current president of United States, it might answer you, it might not answer you, depending on what model you are hitting. The model might be pretty old. It was trained on the old data, so it might not give you the answer for the current situation or the current condition of the question. So it might say that I don't know, or it might hallucinate or give you a wrong output. So that's why in order to keep your model up to date, you need to connect to an external data source which you might be maintaining, and that might give you the correct output. That's called RAG. Okay. The agents are nothing but the LLM applications which not only do the action, not only give you the output, but also do the actions on top of it. For example, you say, I am having some issues in my database or my application, go and fix it, right? So LLMs will see what the errors which are happening in the current application, and it might connect with other tools to fix the errors. So that is the next level. So agents are nothing but AI applications which actually does the real work for you. So those are becoming really popular. Okay, so RAG and agents are both the next level of AI. Excuse me, next level of AI. And the last one we have is LLM OS. See, in the LLM OS, you actually is a theoretical concept which is not available today, but it is actually something which people are talking about it. In the near future, we can have something, a operating system which is completely driven by a LLM. So instead of current Windows operating system or Linux operating system, you can have something based out of LLM which does everything, which integrates with the I/O, the monitors, the pretty much central processing unit. Everything is actually LLM driven, and your complete OS is LLM driven. So that is something theoretical concept now, but it might be a reality next time. Okay. So currently the challenges, I talked about it. The challenges of LLMs include presenting false information which it does not have the answer, presenting out of date or generic information, creating a response from authoritative sources, creating inaccurate responses. Okay, so this is a typical case which I am trying to say. What I am trying to say here is a LLM is someone who is actually enthusiastic about letting you know what it knows, but it might not, and it might say that with confidence, but unfortunately that might not be an accurate thing. So in those cases, you might not want to trust that LLM, right? So that's why you need the RAG architecture, wherein you actually want to feed the prompt. Okay, you give the query. See, you give the prompt and query, then you pass that query to a correct data source. The data source then forwarded that particular data, the relevant information, it is called the enhanced context. Okay, that enhanced context will go to the large language model now, and the model now can predict the correct output. Okay, so instead of directly asking the large language model which is outdated, you are actually taking it over to an authenticated data source which might be up to date, and you are then giving that information to the large language model in a form which it can take, and then it will be able to predict you the correct output. So that is called retrieval augmented generation, where you retrieve the data, you augment the data, and then the model will generate the output. Okay, so that is the RAG. And this is the agent thing is the next level, which we already talked. So it is no different than this. Instead of output, it might actually connect with a tool to give you to do something about that output. For example, if you ask the AI, so the LLM to fix the issue in your machine, it actually went to the database. It saw, okay, this issue is something related to maybe network. It needs to run some commands to fix it. So it got that LLM got outputs that to the particular tool, maybe a command line tool. It writes some commands to the tool. The tool will actually go and fix the network, and then your machine network is fixed, right? Pretty much that is the agent. Agents will do that. Agents are using some external tools to do take the context from the AI or the output from the AI, and then take actions on top of it. That is agent, right? And the final is the OS, right? I already talked about OS, the operating system completely based out of LLM, right? So here you can see the LLM pretty much is acting like a CPU. So everything is connecting to the file system, the terminal, the browser, and other LLMs might also connect to it, the video, audios, everything connecting to the LLM. And this will give us an LLM OS in the future where everything is driven through LLM. Okay, and that's all I had for this presentation. We can go over some questions if you have any. Otherwise, we can wrap up this call. And hopefully next time you all will be able to join next week, next Sunday, and we will take the next course, which is the actual workshop, learning how to use LLMs and how to leverage them in our day-to-day programming. Okay.
Yes, I do have a question, because earlier when you were explaining the concept of agent, it seemed like it was the same concept as diagnostic run when you have error with your printer and it's troubleshooting the error. So is it the same or not? Or
concept of what? Printer?
No, of agent. When you were explaining agent, for me it seemed like it was the same way that when you were troubleshooting a printer, the same way that it works when you go and send.
Yes. So in case of troubleshooting, you're doing manual troubleshooting, right? So in case of agent, you are actually having a proper tool which actually resolves the error for you. So you might have a command line script, some script you might want to run to resolve the issue. You might want to call maybe a database, or you might want to do some other, you might want to call some like Windows program or something which you want to call in order to resolve the issue. So pretty much in agent case, what you are doing is, along with the LLM, you have something externally available for you which can actually help resolve the issues or do some actions on top of it. It's not only for resolving issues, it can take action as well, right? For example, you purchased something, after purchasing, you want to use any tool to maybe generate statistics or data of all the purchases which has happened for today, and you want to connect with some kind of reporting tool. You invoke that action on top of reporting tool, then the reporting tool generated a report of all the purchases which happened today, and then it generated a CSV or a Excel sheet or some kind of web page. Then a manager can go and take a look at it, right? So those are some of the things agent can do. Agents can, I just gave 2 examples, but there are several other things which currently in industry the people are working on, multiple applications, and any kind of application either which is AI related is either falling into the RAG or into the agent category. So these are the 2 things which are prevalent in the AI industry currently.
Thank you. And do we need also to will we be doing some Python programming or no, or it's not required for this class?
Yeah, this class it was only theoretical in nature.
Okay.
Because it was introduction. But next class you might want to come with a proper proper mindset of doing some Python programming, and also with tools like this class would have been fine even with a phone logging. But next time I suggest you all log in through a proper system. So we will do a workshop kind of a thing wherein I'll do some coding and you also follow to it, right? And you will also code.
Thank you very much.
All right. Any other questions before I wrap up? Okay. Thank you very much. Appreciate you joined today, and hopefully we'll meet next time again to get it going and learn more about AI and machine learning. Thank you very much.
Thank you very much.
Thank you for your time.